So Docker, this particular thing will be acting as a platform. Okay, Docker will be acting as a platform. So what is this particular platform? Why do we use this particular platform? Okay, where this particular Docker be used for developing, that means for building up of our applications. Okay, so in a normal way, how we build using our DevOps related pipelines, similar way we used to build the respective application code, which is nothing but a developing, and later the shipping. That means this particular application code which gets built. Okay, so we need to convert the output into a respective Docker images. Okay, so we need to convert our application into a format of a Docker images. And for converting this application into an images, the respective in the respective like a repository, in the respective repository of an application, we will create the Docker file. Okay, so in this particular Docker file, so we need to set what infrastructure that it requires, the application requires to run. Okay, what all parameters was required for that particular application to run, and what respective files are required to run an application. All that we needs to provide. And even as you said that containers, right? So whenever we run this particular images, okay, whenever in the build activity, in respect to build activity of our application code, we will go through this Docker file. Okay, so in this particular Docker file, we will mention, okay, first the application requires a respective container. Okay, it should require a container. Later, that particular container should have either a Windows or Ubuntu or Red Hat, so whatever operating system it was, you need to mention that. So in which platform that your application should run or supports. And later that, definitely, like in which programming language that your application is, whether it is a Angular, JavaScript, or whatever it might be, no issues. So you need to specify that as well. Okay, and later what files are required from the build pattern. What are the files which we call the artifacts? Which artifact or which package was required? Which packages are required to run your application? Okay, and later, after taking that particular files, package files, later, if you want to run your image, okay, after this particular Docker build activity, we will get created one of a Docker images, and when you run that particular Docker image, the container should get created. So how your container should launch? What are the prerequisites that you want to give? Is there any execution commands that you need to pass? All that also will be specified inside a Docker file itself. Okay, so to convert any application into your respective Docker related images, so the most important thing is that you should be aware of this particular Docker file. So how you need to write that particular Docker file? What is the importance? Everything we are going to see. Okay, and later this particular Docker image, we cannot leave it like that, right? So once the pipeline about to exit, we cannot leave that. So we need to push that particular Docker image towards some centralized space, towards some centralized space. For that, we had Azure Container Registries. To store these particular images, we generally use ACR, Azure Container Registries, or the open source we have Docker Hub, or the open source we have a Docker Hub, or you can generally store it in our storage accounts as well, no issue. Okay,
Chandra, what are the registers, Chandra?
can I come again? Registries.
You said ACS, right? Azure Container Registers.
Azure Container, yeah. I will let you know. Okay. So ACR means Azure Container Registry. So this is the place. This is the place where we used to store our Docker images. Okay. So similar to see, what is a GitHub? So we have gone through this
GitHub,
particular Git.
yes,
So what is this
where
GitHub?
we store the code.
Where we store the code,
Code.
or what we can say is where we create the
Repository.
repositories and store the application. Similar scenario. Okay. So the place where we are going to store our
Okay, okay,
Docker images. So similar kind. Okay. But here somewhat versioning and all that will be coming. I
okay,
will show you that. No worries. Okay.
okay,
So Azure and Docker Hub. So these are the places that we are going to store our images and later running up of the applications. Okay. So from that particular place, we will pull the respective images whenever we require, and we will create an application. So all this is good. So whatever the platform, Docker platform is used to build, Docker platform is used to ship the images, or Docker platform is used to run the applications. Everything is fine. But to do all of these particular activities, what do we use? What is the backend activities that a Docker is utilizing? Let's see that. So here we will be majorly having a two. One is a Docker client and the Docker daemon. Okay, let's see that. So the first one, Docker client. Sorry, step into this here. Okay. So the Docker client. So in this particular Docker client, we used to provide. So this particular Docker client will be like CLI. Okay, command line interfaces. The Docker client will be acting as a CLI. Okay, from this particular Docker client will take the respective Docker commands. Okay, so whatever the Docker commands that we are going to pass, all that will be taken into the client. Okay, I'll just put it here. Very fast. So here, whatever the commands that we need to use, like for building up of an application or for running your respective images or for pulling any other externally registered images. Sometimes we will be using already existed images as well. Okay, sometimes whenever there is a requirement, so we can pick up the existing images as well. So let me give you that here. Imagine this is a client, and inside of that, let me place some basic comments. So there are a lot of other. I'm just placing some major, which are a very fundamental one. So Docker run, Docker build, and the respective Docker pull. Okay, so when these particular commands, whenever these kind of a commands you are given inside of any of a CLI, okay, Docker related commands, whenever you have provided, by default it will be listened by Docker client. Okay, so this particular Docker client where Docker uses to interact, okay, where the users used to interact with the Docker using this particular Docker client. Okay, so there is no specific plugin for this. Okay, so whatever the plugin that we are going to install is Docker engine. Okay, in that particular Docker engine itself we will be having a client and Docker daemon, everything related to the Docker. Okay, so in that, one of the component is nothing but a client, Docker client, and this particular Docker client will listen towards your respective Docker commands. Okay, and later whatever the commands that it listened, that particular commands will be sent towards a Docker daemon. Okay, so this particular Docker daemon listens to our Docker API requests, that means our Docker clients, and it creates, what we can say is like it executes whatever the commands that we provided. The Docker daemon executes. The client role is just to listen towards our commands and record, and later that the client sends the respective commands towards our Docker daemon. Okay, let's see. So the entire, so let me take it as a host, Docker host. Inside of this particular host we used to have our Docker daemon. Okay, so now whatever the commands, all will be passed towards here, towards this Docker daemon. Every respective command will be passed towards this particular daemon. And now this particular Docker daemon, where generally people will be calling this as Docker D as well. Okay, Docker D or a Docker daemon, everything is same. So now this particular Docker daemon depends upon your respective commands. For example, if you want to pull, if you have given a Docker pull command, okay, so there will be a specific service, or we can say a resource, like Azure Container Registries or whatever the plugins we can say. Let me take this as a registries part. okay, where the Docker images initially used to be available. Okay, or whenever there is a certain commands like a Docker push as well. After you are creating your image, you can push it towards a registry. But whenever you require a respective image, you can pull that. Pull means get, right? So from this, first let me see on the Docker pull. Okay, if you are going to use this particular Docker pull and the Docker daemon listens to this, and now this particular daemon looks over, okay, from which respective source that it needs to be pulled. Okay, so that particular source will be attached in that image itself. So Docker pull, and we will provide the image ID and the respective image version as well as an extension here in the command. So in the Docker image itself, it will be mentioned. Then the name of a Docker image itself, it will be mentioned which repository, which container repository that you needs to get or reach. And in that container registry, which version of the image that you want to pull, everything will be there in that naming convention of an image. Okay, we'll see later. Okay, so now Docker pull and the respective image. So here let me take something like ACR, the registry as an ACR. Here I have something like related to Nginx, something a lot of other. Okay, so Nginx related or plugins related or whatever the extensions, everything was there in the registries. So whenever I try to pull this particular Nginx related image, so this particular image will come towards our host. The Docker daemon brings the image from this particular registry towards the host. And we call this as an images. So this particular Nginx will be called towards here. Okay, so here you can, whenever you give something like a Docker your image from the registry, it was called towards here. Next, you have given something like Docker run. You have given something like a Docker run. That means your image, whatever your image, this should be converted into a Docker container. Okay, this particular image will be converted into the respective container. See, let's first, it will be the Docker daemon will be requesting the Docker registries, or we can say container registries, that I want a specific image. And when that particular image when that particular image was called towards our Docker host, and here the respective host, in a sense, the place where you are executing commands. Okay, so here a Docker image reference will be called similar, like however you are doing a git clone, right? So whenever you do a git clone activity, what happens? Your repository will comment it in your local machine or whatever the machine that you are calling from, right? Similarly, your Docker image will be called, and that will be available as a reference in your workspace that you are working on. And from there, once the respective Docker image available in your space, you will be undergoing with the Docker run and the respective image ID. Okay, Docker run and the respective ID. So what will it is going to do is, whenever you perform Docker run and the respective image, the image is going to be converted into a container. So inside of this particular container, you used to have you used to have a respective application related towards your image. For example, here I have taken something like an nginx image, so that when a respective container has been created, in that particular container you used to see something like nginx related application or nginx related services. So depends upon the image that you pulled. So sometimes the images will be having the applications, or sometimes the images will be a part of a plugins, or sometimes it's part of a softwares, anything. You can store any kind of a thing in your docker images, softwares, or whatever the plugins, or whatever the applications, anything you can store. Okay, so this particular docker images are very lightweight when compared to our general virtualization method. This particular images are very lightweight. Okay, that means you can move these particular images from one place to the another place with a less the image size will be very little when compared to the others. But to make that compressed size, that depends upon the DevOps engineers as well. Again, you need to be very clear what are the steps that you needs to be placed to create a docker image. Are you giving the exact steps or not, or you are placing any unwanted steps in your docker file? So everything is important. So based upon your docker file itself, your docker application, your docker images will get created. How much size or whatever the things, all that depends upon our docker file itself. Okay, and here as I shown here, docker build. Okay, so docker build, when we will be using this docker build is at the initial step, at the initial step. That means if you are not having any of an images in your registries, that means if your registries are empty, that your private registry is empty. Okay, and you had your application code ready, and you have created a docker file for that. Then if you are going to give something like a docker build, let me give you in a series. Okay, here the process. So imagine that there is a docker file exist in our repository, general GitHub repository only. Okay, along with our application code, our docker file will be available inside of a repository. And let's take that we are going with some DevOps CI CD task, or something like a CI task. That's fine. CI task. That means here I would like to first build my application. That means some people will be using, see for example, if you are going to check some Java related code, so Java compile or whatever the things that you will be doing, right, for building your application. So all that will be done, and later, so which kind of a build that you want to perform, whether NuGet or what kind of npm builds, or what kind of a build that you want to perform. So depends upon again our respective Gradle or Maven or Ant. So depends upon the project that we will be using. Whenever you perform this build activity, okay, so your application will be converted into a package. Whenever something like a application build was happen, this is not a docker build, this is an application build. Whenever this particular application build was happen, your application will be turned into a package, either a var or a jar or whatever the format, zip or 7-zip, into a respective package. Okay, now in a general scenario, in a general virtualization model, we will be traveling this particular package towards our server directly. We will travel this particular package directly towards our server. Okay, but here in the Docker, we are making it more simple at the server level. That means whatever the application that you are creating, that particular application is going to be independent of operating system, independent of your operating system. Okay, for example, can anyone let me know if you have any idea? Just guess. Okay, so um, there is a server. Okay, so that particular server is some Windows based operating system, and in that particular Windows based operating system, I have installed some Java 8. I have installed some Java 8. Okay, and my particular application is Java 11 supported. My respective application is a Java 11 supported. Will my application run as expected in that particular server? Will that be possible?
No.
No. So in that particular server, we definitely need to deploy or maintain Java 8 related applications, right? And to make that happen, again, you need to create one more server, which is having a Java 11 installed, right? That means in a Java 8 related server, you cannot install a Java 11, and in a Java 11 supported, if you are going to install Java 8, some of the work phrases can be worked or some might not work, but it is not suggestible, right? In such cases, two servers needs to be maintained. Okay, here the Docker images, so whatever it might be, we are going to see something like container services. What? Container services. So these particular container services independent of your respective operating system. Okay, so your application, so now what runtime, that means your programming language support, that will also be part of your container itself. Inside of your container itself, your runtime will be available, so that in a single container service you can create a n number of, or we can say something like up to 250 something, 251 or 252 containers we can create. But in earlier virtualization model, only that Java 8 related applications can only be installed. But now you can install Java 8, Java 11, Java, whatever, Python or Python different versions, anything you can install in the format of containers. Let's see that. Now this particular package using a Docker file,
In the same container, Chanda.
not in the same container, in a container service. Okay, each container will be
Okay.
supportive for one application. In each container we can have one application. It might be either Java 8 or a Java 11. Okay, but instead of separate, we can say like, I will just give you a draft after this. Yeah, I'll just give you. So from whenever you are doing, after this particular package was done, you need to give something like a Docker build. Okay, Docker build. So this particular Docker build command will refer towards our Docker file. Whatever the Docker file is there, this particular Docker build will refer towards our Docker file. Okay, in this particular Docker file, we will be initially specify, okay, for this particular application, we required something like a Java 8, and later, if this particular application requires something like MySQL plugins, so call that as well. And later, create one of a for example, if you are going to use something like a Tomcat servers, so call that. And if you want to place your application in a specific path, so create that using mkdir or whatever the commands that we see in a bash scripting. And later copy the package. Okay, this particular package will be available, right? Copy this particular package into a respective path, a respective path. And later whenever you are trying to run an image, okay, before image and after image, everything will be given inside of a docker file itself before creation, while creation of a docker image, and if your docker image is created, and if your docker image is going to run, all that will be specified in your docker file itself. Okay, and after that particular copying of a packages, you will mention if someone runs this particular docker image, so what is the prerequisites that you use to execute? What are the things that needs to be set up first? And do that particular container requires any of a plugins or something like that? So everything you will provide. And later whatever apply command, that means a deployment command will be given in that itself. Using that, your application, see, generally whenever we are copying a package means inside of that particular package we will be having something like application file, that means .exe or .msi or .app or whatever the file extensions, right? So once your container is about to launch, okay, once your container is about to launch, run this particular file so that your application will get created. So the docker build, so once this particular docker build is done, you will be having a docker image. You will be having an output called a docker image, and this particular docker image, you needs to push it towards some centralized space, and we call that as a container registries. So it's common across all the cloud platforms, AWS or Azure or GCP, any cloud platforms. You would like to push your images towards the concerned container registries. In Azure, we had Azure Container Registry. Towards there, we are going to push our respective images. Okay, and it will be stored there using a version itself. Every time whenever you perform a docker build, a new version will get created and it will be pushed towards here. So to push it towards here, we need to give here something like a docker push, as well. Once the image is generated, you need to do docker push. Similarly, how we will be doing a git push, right? After our commit was happened, git commit, after our git commit was happened, what we are doing to update our remote location, we are doing something like git push. Similarly, to update your container registry with the latest build versions of the image, you will be doing a docker push. So all this is good. Later, whenever you are trying to deploy, see, that means from this docker build using a docker daemon, everything, so the respective image was happened here, created here in the registry. Later, whenever you are trying to whenever you are trying to get this particular image into your respective container format, whenever you are trying to convert your image into a container format, first you need to do a docker pull. Pull command needs to be done from your container registries, so that what happens, your respective image will be available at that particular workspace, at that particular workspace. That means your web application server or a container server, something like that, in a container service. And later, once your image is available at a workspace, So you will be performing a Docker run. Okay, you will be performing a Docker run command. So this particular Docker run command will create the container inside of that container services. Okay, inside of that particular, for example, if let me take this. So imagine this as a container services. Container services or a Kubernetes cluster. So in both the places we will be using a Docker images only. So in this particular container services, what your respective container should get created. That means in the entire of this container services, you will be having one of a container. See, not entire space. You will be having your like what depends upon the resource and the memory and the CPU that you provide in the commands. So using that particular space only, your container will get created. Okay, so imagine that this particular container from our Docker file, this particular container is getting created, and this is based out of Java 8. Okay, Java 8 based container gets created, and inside that our application from this particular package which our copied, that will get launched. Okay, and later in the same container service you can create, you can set up, okay, I can say you can set up something like a Java 11 based container as well, where you can maintain Java 11 application, and in the same the other version of a Java as well. Yes, whatever you want, whatever the different version of your programming languages can be maintained in a single service, or you can have it here Python, Python based containers, Angular, React, JavaScript, or whatever. Even your database, MySQL database servers can also be maintained as part of our containers. That means we can create a database container inside of our container services. So earlier, see, again this particular container services is not a big thing. Okay, this is similar to our web application server only, just the naming convention is different. But at the back end, back root functionality, they will take virtual machines only. Okay, this particular container services or our web application servers. So both, in both the cases, the root case, the root machines is nothing but our virtual machines. Okay, but whereas that particular web application server will be support you only to platform dependent applications, but here in the container services, platform independent applications, right? That's the reason today we are um, having a lot of activities related to the Docker and the Kubernetes. Instead of creating multiple web application servers in a single server itself, we are going to maintain different versions of your applications. For example, today there is a .NET 6 application, okay, and I need to upgrade it towards a .NET 8. In our virtualization method, what we need to do first, I need to update. See, for example, first I need to update my web application server towards .NET 8 support you. That means .NET 6 to .NET 8. Okay, at that particular point of time, what it will be happening, if my code was not ready, the .NET 6 code, some of the features will not support you towards the .NET 8. Right? There will be some ups and downs there in the performance. And later, After you are deploying your code, which is updated towards .NET 8, when it gets deployed, it will function fine. But here in this container service space, in one of a container you can maintain .NET 6, and in another container you can maintain .NET 8. That's up to your preference, right? And for each, and you might have a question, okay, whether this particular containers will be having any naming conventions or something like that. Yes. So this particular container will be given with a container name. That means your application name will be given to this containers. And every time whenever a container gets created, so you will get one of a container ID. So container ID will get generated for each and every respective containers. Okay. This is the basic outline how the Docker is going to perform. So all these places we are going to touch: the Docker files and application build activity and packages, everything. Okay. And later, let's see some. Let me try now to give you some basic outline. See how in the virtualization and how in the containerization how it will be there. Let's see. First, for any kind we require something like a hardware. Here to do this. So for any kind of a thing we require something like a hardware, and later something like host OS. What am I doing here? Let me give it here in a brief. Host hardware, and above that we used to have something like host OS, and later that hypervisor, right? We had seen this when we are discussing on VM. And later, to maintain your application upon this particular hypervisor, we used to maintain the respective guest OS. Guest OS. And upon this particular guest OS, you will be deploying your respective application. For example, if it is something like a Java 8 and with the Windows, so you need to deploy only that specific applications, right? So this is a virtualization method. And when coming towards our container, same, we will be having the hardware, and later the host OS. Base will be the same. So instead of our hypervisor, here we will be having a Docker engine. a Docker engine. That means all the Docker related components will be installed instead of a hypervisor. Hypervisor, as we said, that it is a medium we choose to communicate between a software and the hardware. Here, the Docker engine will be used to install all our components related towards our Docker, and we choose to take all our Docker inputs and all that related stuff. Okay, and now here, instead of a guest OS, we used to create, or we used to make this available with libraries or a bin folders. Okay, instead of a guest OS, we used to create for a containers, we used to set up bin folders or a libraries. So upon this particular bin or a libraries, we used to deploy our application. That means you can call up the libraries related to Java 8 so that Java 8 can install. If you would like to call up of Java 11, so Java 11 can install. .NET 6, .NET 6. So like that, irrespective, see here the guest OS, but here we used to call up of the respective libraries. Depends upon our programming language that we use. We used to call the specific libraries so that that programming related application can be run inside of our container. See, both this will be a part of a container. Whenever container is about to launch, you will be calling a respective programming dependent libraries, and that particular application will be function. Okay.
So, as per your saying, different containers for different versions, right, Chandra?
Yes.
So, my question is, how can we create different containers?
How can we? Yeah, that see. That's what. No. How can we create the different containers? Means a Docker run command. So whatever our Docker run command is there, right? This particular Docker run command. So
Okay.
Docker run and the respective image. See, for all the respective containers, we will not give same image ID. For
So,
Java,
as per you said, if we use the Docker run command, Docker runs space some image names like Microsoft, it will create a different container ready when we are
yes,
running
yes,
again and again.
yeah, yeah. So
So,
for
based on
each,
that,
for example,
so my question is, how can that version will change? So if we run the same command, it will get the different ID. So how the version, as per your said, saying
Docker image
versions, right?
versions you
Java
see.
8. Okay.
See, that's what I am
So
saying. No,
those
so
can be
whatever.
pulled.
See, one thing. Listen to me first, okay? So whether you are
Okay,
using,
okay,
if you are trying to create a Java 8 related application in the Docker file, you will be creating a Java 8 related stuff. That means you will
okay,
be importing Java 8 related libraries, and you will be undergoing all of this thing so that a Java 8 related container will get created. And if you want
okay,
Java 11, then you need to create a one more Docker file for Java 11 support your application.
okay.
See, in a single repository, for example, you have created some GitHub repository, right? In that
Yes.
particular GitHub repository, will that be possible to maintain two different programming versions of a code?
No.
Definitely no. For each version of a repository, for each version of a program, sorry, for each programming language application of a version, we will create one repository, right? Similar
Yes.
case for whatever, for Java 8 related application, you will create a Docker file which supports Java 8 related libraries. And in the other repository application, if that particular application is dependent on Java 11, so you will create a Docker file related to that Java 11 libraries, and you will perform all of this.
Okay.
Okay, here the scenario is you will not push all the images into a single registry. You are not supposed to push all the images. For example, Java 8 related images towards, for example, let me take here something like example 1. So example 1 is a container registry. Okay, so
Okay.
in a real world scenario, we will not supposed to push Java 8, Java 11, Python, or whatever npm or whatever NuGet, all the images towards a single container registry. We are not supposed to do that. Okay,
Okay.
for
Okay.
each application type we will maintain one container registry. Okay, for each application one container registry. For example, example 1 will be used for Java 8, example 2 registry will be used for Java 11. So like that, different registries for different programming versions or different applications, I can say. Instead of a programming languages, we can say different applications. For each application version, we can for each application we can maintain one container registry. Okay, so whenever, so Docker file build package and Docker build. So for this particular build, let me take this as a first build. So one image one will be going here and sit here in the registry. Whenever you pull Docker pull with the image id, that means the image one, it will come towards your workspace. And whenever you run that Docker run and that image id, a container with that particular thing will get created. And later again, if you do a Docker build, right, that means the second build, the image version will be updated. That's what, no. So today the application has some code, tomorrow or the next week the developers will create some more code, right? For that particular code you need to have some more version updates, right? So that particular version updates is nothing but Docker build. From the Docker build activity we will get that version updates. Whenever you run the build activity multiple times, the versions will get updated. Okay, now image 2. So here whenever you are trying to pull, make sure that you are pulling updated image. Okay, sometimes what people will be doing is after the respective image version gets updated also, they used to pull the old versions, like a Docker pull image 1 instead of a Docker pull image 2, they will be pulling Docker image 1. In such cases what happens, there is no, you cannot see the update in your application, right? Instead of that, you need to do Docker pull image 2, same process again, a container, sorry, again a container will get created for Java 8. Okay, like that. So
Yeah.
each
Okay.
registry, but what the thing is, you can maintain, there is an option, you can maintain multiple application in a single container services. Multiple applications in a in a single container service. Okay, so
Yeah.
earlier one is for app application one, we will be maintaining one VM. For app 2 we will be maintaining another VM. Instead of that, in a single VM itself we can maintain app 1, app 2. So like that, so you will get a clear picture when I show you that with some commands and all that. Okay,
Yeah.
clear?
Okay, sir.